If you have been writing ABAP for a decade, you know DynPro screens, selection screens, and ALV grids. They work. They have worked for 25 years. But SAP has drawn a clear line. The future is powered by RAP. This is not just a new UI framework. It is a completely different development paradigm. Instead of painting screens and writing event handlers, you define data models in CDS views, declare behaviors in behavior definitions, and let the Fiori Elements framework generate the user interface from annotations. In the next few minutes, you will learn the core building blocks and how they fit together.
3 forces are driving this transition. First, user experience. Every Fiori Elements app follows the same UX patterns: list reports, object pages, overview pages. Users learn one pattern and apply it everywhere. No more custom screen designs that look different in every transaction. Second, development speed. SAP estimates that Fiori Elements apps require 60 to 80% less front-end code than Freestyle UI5 apps because the framework generates the UI from metadata. You spend your time on data modeling and business logic, not on layout and rendering. Third, upgrade safety. Because the UI is generated from annotations, SAP can update the rendering engine without breaking your app. Your CDS views and behavior definitions remain stable across upgrades. Custom DynPro screens, by contrast, are frozen in time, and every UI change requires manual development.
Provides 4 primary floor plans, each designed for a specific use case. The list report shows a filterable, sortable table of records with a smart filter bar at the top. Think of it as a modern ALV grid. The object page displays the details of a single record with header sections, facets, and subsections. It is the detail view you navigate to from a list report. The overview page displays cards from multiple data sources on a single dashboard. Each card can show a chart, a table, or a list. It is designed for role-based landing pages. The analytical list page combines a chart and a table with interactive filtering. It is built for data analysis, where users explore data by drilling into chart dimensions. Most transactional apps use the list report plus object page combination. Analytical and overview pages are used for reporting and monitoring.
Everything starts with views. A CDS view is a declarative data model defined in the ABAP development tools, also known as Eclipse ADT. Unlike classic ABAP database views, CDS views support annotations that control everything from field labels to UI behavior. There are 3 types of CDS views in the RAP stack. Interface views define the base data model and associations. They represent your entity structure. Composite views add UI annotations on top of interface views. They control how fields appear in the Fiori Elements floor plan, which fields are filterable, which show in the list, which are hidden. Projection views define the public API surface. They expose only the fields and associations that your service needs, following the principle of minimal exposure. These 3 layers separate data structure, UI presentation, and service definition into clean, maintainable artifacts. Are where you declare what operations your app supports. In classic EBAP, you wrote event handlers in PAI and PBO modules. In RAP, you declare capabilities in a behavior definition file and implement them in a behavior implementation class. A behavior definition declares standard operations like create, update, and delete. It declares actions, which are custom operations like approve or release. It declares derives, which are automatic calculations triggered by field changes, and it declares validations, which are business rule checks that run before save. The key shift is from imperative to declarative. Instead of writing on user command save, do these 10 things, you declare this entity supports create, update, and delete with a validation that checks the status field.
The RAP framework orchestrates the execution. Once you have CDS views and behavior definitions, you need to expose them as a service. A service definition lists which CDS entities are exposed. A service binding binds that definition to a protocol, either OData version 2 or OData version 4. In the service binding editor in Eclipse ADT, you activate the service and can immediately preview it in a browser. The FIORU Elements UI is generated at runtime from the CDS annotations in the service metadata. You do not write any front-end code for a standard FIORU Elements app. The framework reads your annotations, builds the list report columns, generates the filter bar, creates the object page facets, and handles navigation. UData stays entirely in the ABAP backend. Annotations are the bridge between your CDS data model and the Fiori Elements user interface. There are three categories. UI annotations control the visual layout, which fields appear as table columns, which appear in the filter bar, which are grouped into facets on the object page. Common annotations include @UI.lineItem for list columns, @UI.selection field for filter bar fields, and @UI.facet for object page sections. Search annotations enable free text search on specific fields. Common annotations include @search.searchable and @search.defaultSearchElement. OData annotations add metadata like value helps, text associations, and faucets. For example, @consumption.valuehelp on a status field generates a drop-down with predefined values. The power of annotations is that you change the UI by modifying metadata, not code. Moving a field from the filter bar to the table is a one-line annotation change, not a screen redesign. Let us walk through the end-to-end workflow for building a transactional app. Step 1. Create your interface CDS view with associations, key fields, and base annotations. Step 2. Create a consumption CDS view that adds UI annotations on top of the interface view. Step 3. Write a behavior definition that declares create, update, delete, validations, and actions. Step 4. Implement the behavior in an ABAP class with methods for each declared operation. Step 5. Create a service definition that exposes your consumption view. Step 6. Create a service binding, choose OData v4, and activate it. Step 7. Preview the app directly from the service binding editor. Step 8. Register the service in /SAP/MAINTSERVICE on the front-end server and create a Fiori Launchpad tile. This entire workflow happens in Eclipse ADT. No SE80 or SAP GUI screen painting required. If you are coming from classic DynPro, the biggest mindset shift is moving from imperative screen events to wrap. Start with a simple read-only list report. Create a CDS view on an existing database table, add UI annotations for 5 or 6 fields, create a service definition in binding, and preview it. You will have a working Fiori app in under an hour without writing a single line of front-end code. Once that clicks, add a behavior definition with create and update operations, then add validations, then actions. Build incrementally, and the wrap will become second nature. The DynPro era is ending. The developers who learn RAP now will lead the next generation of SAP development.